One of the important things our atmosphere does is control how much precipitation falls on Earth. Precipitation is just water that comes down from the sky. That could be as rain, it could be as snow, it could be as hail, any other form you can think of. Some places on Earth have lots of precipitation. They're very wet climates. If I was doing this in Seattle or Vancouver, I'd probably want an umbrella right now. But I'm in San Diego and it's another typical day here, blue skies, no rain. Why is that? Why is it that some places on Earth have lots of precipitation, whereas other places tend to be very dry climates? Turns out it's a pretty simple reason. It has to do with whether the air is mostly rising upward or mostly sinking downward. I'm going to draw a quick sketch for you on the board of how our atmosphere circulates. What you can see here is this diagram of the globe with the North Pole up here and the South Pole down here and the equator in the center, and then 30 degrees north and 60 degrees north latitude, 30 degrees and 60 degrees south latitude. What we find is that the equator is the place that receives the greatest amount of solar energy on Earth. The sun shines at a high angle there and really heats the atmosphere. And so the air tends to get very warm and it tends to expand and become less dense, and so it tends to rise. And I'll just show that by showing arrows showing the air rising upward. Okay? This is just going to be a two-dimensional view of something that's happening over the whole planet. So right here, for example, the air is rising out of the board toward you. Okay? What happens to this rising air is it tends to turn and head toward the poles, both to the north and the south, and then by the time it reaches about the 30-degree latitude belts, it becomes cooler, and so it tends to contract and sink back to the surface of the Earth. And some of that air heads back to the equator, and some of it heads away from the equator toward the poles. Now, at the North and the South Pole, it's kind of the opposite happening. The air is very cold, and just as hot air expands and becomes less dense and wants to go up, cold air pulls together and becomes heavier and wants to sink. So the air tends to sink near the poles, and what will happen is it doesn't really have any choice but to try to go toward the equator. Again, that's happening all over the place. I'm just doing this in one part of the diagram. So the air sinks and moves toward the equator in both the north and the south, and what happens is this air ends up colliding with the other air that's heading toward it along what we call polar fronts, and it forms other somewhat less well-developed circulation cells. Okay? But the key thing that we can notice when we sketch out the atmosphere like this is that we can recognize specific belts, regions, where air generally tends to rise or where air generally tends to sink. And this turns out to relate very closely to how much precipitation we get. The equator, which is where the air is rising, turns out to be a very wet climate. More rain falls in the tropics along the equator than anywhere else on Earth. Where the air is sinking at around the 30-degree north and 30-degree south belts, those tend to be our dry climates. If you look at an atlas of the world and look where the big deserts are, like the Sahara and the Kalahari deserts or the great deserts of the southwestern United States, you'll see they sit along that 30-degree belt. As we move up to about the 60-degree north and south belts, we tend to get wetter climates, higher precipitation. So this would be, for example, northern Canada or Alaska. And then as we move to the poles, we actually have areas of sinking air which correspond to mostly dry climates. I know that might seem strange because there's all this snow at the poles, but the net precipitation, the amount that it snows every year at the poles is actually very little. It's so cold that that snow tends to stick around. So where we have areas of rising air, we tend to have wet climates. Where we have areas of sinking air, we tend to have dry climates.
You can see these patterns on a satellite image of the Earth. Look at that band of clouds right along the equator where the air is rising. Go north and south of there to those bands of clear skies where the air is sinking. North and south of there, you see more clouds in the 60-degree latitude belts where the air is rising.
So let's figure out why it is that areas of rising air tend to have high precipitation, whereas areas of sinking air tend to have low precipitation. Well, in my diagram here, what I'm showing is that if you have an area of air near the surface of the Earth that begins to rise, what happens is it expands. And the expansion means that the air cools down because the molecules in the air are not fighting for as much space. The same number of molecules is spread out over a smaller area, a larger area, and so they don't bump into each other as much and everybody slows down, and that means the temperature drops. When the air cools down, it becomes easier for any water molecules that are in the air to get together with each other. The water molecules will hit each other and they're electrically attracted to each other, and so they'll tend to gather. And if they form drops that are big enough, the drops begin to fall out of the sky. So areas of rising air expands and cools down, and you'll tend to get higher precipitation in that area. Very important that you have an accurate diagram when you do this. So I need an umbrella here for my little guy, because it's raining. In areas of sinking air, we've got the opposite situation happening. If air high up in the atmosphere sinks down toward the surface of the Earth, it tends to squeeze together because there's more weight of the atmosphere on top, and so it's squeezing it together. When you compress the air, it tends to warm it up because you're crowding the same number of molecules into a smaller space, so they start bumping into each other and everybody starts vibrating and moving faster, and that means it's getting warmer. When you do that, all those air molecules zipping around means any water molecules that get together get knocked apart, and so it's very hard for water molecules to form drops in that situation. So areas of sinking air where the air compresses and warms up, those tend to be your dry climates, areas of low precipitation. Here you're going to want to have not an umbrella, but a hat, because it's sunny. This device here will help me illustrate these points I've been trying to make. This is called a cloud maker. You can see it's a glass bulb, and there's water there in the bulb. And even though we can't see the water molecules in the air, we can be pretty confident that the air in here is very humid. But there's no cloud there, there's no rain. Well, in the atmosphere, when clouds start to form, what happens is the water drops typically try to nucleate around little bits of atmospheric dust. And we're going to mimic that here by I'm squeezing the bulb and squeezing some air out and clamping the tube. And I'm going to suck a bit of smoke in to mimic the kind of dust that you might get in the atmosphere where you might get a cloud to form. How about, there we go. Okay, so we're going to suck a bit of smoke in. And then when I squeeze the bulb, that's mimicking what happens in areas of sinking air. You squeeze the air and it warms up, and you don't tend to get a cloud to form. But watch what happens in the bulb when I let the pressure off here. When I let the pressure off, you see how a cloud forms. Water molecules are able to get together because the expanding air cools and allows them to condense around little bits of dust. Squeeze the air, and the cloud goes away. That's like air sinking toward the surface of the Earth, compressing and warming. Let the pressure off the bulb, and a cloud forms. That's like air rising, expanding, and cooling. So in areas of the Earth where we have sinking air, we tend to have low precipitation. In areas of the Earth where we have rising air, we tend to have cloud formation and high precipitation.